Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called SVS number 452, Some Skyscrapers by Richard. And here are the rules. We have apply classic Sudoku rules, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Each digit represents a skyscraper of the corresponding height. Clues outside the grid indicate the sum of the visible buildings from that direction, where higher buildings block the view of lower buildings. So, what does that entail? Let's basically try to come up with an example here. We have, let's have, maybe not there. Let's have, actually we could have it there. Well, let's make it here, 9, 8, and 5. 3, 1, 4, 6, 7, 2. So this is an example of a row that we could have, and this would be a valid example for the skyscraper sums. Or the some skyscrapers. Wow, that's a kind of a tongue twister. Some skyscrapers. Because it's what digits does it see in this row for this 22 clue? It would see this cell. It would not see any of these because they are lower than the 5 in front of it. It would see the 8. It would not see the 4 because it's lower than the at least one of these digits in front of it. It would see the 9, and it would not see any of these cells because these cells are smaller than at least one of the digits in front of it. So again, clues. Okay, so each digit represents the skyscraper of a corresponding height. So this would be height 5, height 3, height 1, height 8, etc. And since lower buildings are blocked by higher buildings, it sees only the 5. It does not see the 3 or 1. It sees the 8. It does not see the 4. It sees the 9, and it does not see 6, 7, and 2. Now, if you add up the values or the digits of the skyscrapers it sees, 5 plus 8 is 13 plus 9 is 22. So that's why this would satisfy this some skyscraper clue, right? So this is an example of how some skyscrapers work. Okay, I'm getting better at saying that. That's hard to say. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. Every some skyscraper is going to include a 9. So the question is, how do you get the sum that we have? So for 12, it could be 1, 2, 9, or it could be 3 and 9 that it sees. That means for the 12 clues, the 9 has to be either in one of these 3 spaces here. So we'll mark that as red for where the 9 can be in that column or row. So 9, it could be, again, 3 and 9, or 3, 1, 2, 9, or 1, 2, and 9 specifically. Right? So 9 could be any of these. So it's the same with this. So this can't be 9. This can be 9, or this could be 9. That's interesting. This sees 9 going this way. So, okay, so this one's the interesting part, because we have skyscrapers seen going that way and this way. If we had a 9 here, I guess we could have something like 3, 8 in front, and that would work. Huh. This is either 3, 9, or it's 3, 1, 2, 9. Right? Because it can't be 1, 2, and 9 here. So this has to be a 3 no matter what then. Right? If we have either 3 and 9 to add up to 12, or it's 3, 1, 2, 9, adding up to 12. Because it sees just the 3 and the 9. It can't be 1, 2, and 9 that it just sees. Because there's no possibility for 9 to be here because of the restriction in column 3. So this has to be a 3. We know that for certain. So this is 3, and either this is 9, and or this is 1, 2, 9. Okay. Can 9 be here? You can only have 6, 7, 8, 9 if it were the case, and therefore it cannot be there. So it can't be 6, 7, 8, 9, because that would only add up to 30 at most. So this cannot be the 9, which means 9 has to be here in this row. That means this cannot be 9. So this can't be 9 to add up to 32. So anything 30 and above, the 9 cannot be in the first 4 digits. Okay, so that's for 31, for 38, no 9. 32 could be any of these. So 9 has to be one of these two. Then in column 3, which means 9's one of these 3 in column 1. Obviously, it can't be here. Oh, that's one thing. Where can 9 be in any of column 1, row 9, or column 9? It cannot be next to any of the some skyscraper clues because it would have that some skyscraper clue must be 9 if that's the case. So this can't be 9. This can't be 9. This can't be 9. This can't be 9, and this can't be 9. To add up to 38, it would have to be 1, 2, 3, 4. You cannot have 5 digits because that would be 35 at most. So this doesn't work that way. So one of these two is the skyscraper, which means none of these can be the skyscraper, or one of these has to be the 9 in column 9, which means none of the rest of the box can contain 9. Okay. What about 28? You cannot have 3 digits adding up to 28, and we already know 9's here. So this cannot be 9 here. No 9 here, no 9 here. This can't be 9 because of 9 in the box. So one of these two is 9 again. 21. You have, it has to be 5 digits and then a 9. Because 4 digits and a 9. Because it cannot be 5 digits and a 9. 5 digits at minimum adds up to 1, 2, 3, 4, 5, which is 15. Plus 9. So this can't be 9, which means this has to be a 9 here. So this is 9. It must see 4 of these digits, and that must add up to 21 minus 9, which is 12. So it's 1, 2, 3, 6, or 1, 2, 4, 5. So it's 1, 2, and then we have 3 and 6, or 4 and 5 here. And it must, again, see all of those digits. Oh, this is supposed to add up to 25, though. How does that work? That's not going to work. Huh. Huh. Oh, it doesn't have to be 3 digits. Sorry, it doesn't have to see 4 digits. It could be see 3 digits here. Or even 2 digits. Okay, well that shows that you cannot see all 4 of these digits here. So it must be 2 digits or 3 digits that it sees here. So this cannot be 1 and 2. It has to see all 3 of these digits plus the 9 here to be able to add up to 25, right? Because 3 digits only adds up to 24. Interesting. So these digits add up to 16 without a 9. It could be something like 178. That's interesting. That means also 9 cannot be in the rest of this box. It cannot be here, either in the rest of the column. This is 15. 21 cannot be 2 digits. So this cannot be the 9 here. So 9 has to be one of these 2 digits here. Which means this cannot be 9. So 9 is one of these 2 digits here. Okay, 15 could be 2 digits adding up. This is 32, and the 9 could be any of those digits. So this must be... It must see all 3 of the digits, and it adds up to 16. What's the smallest this could be here, then? It would be 6, 7, or 8? Can it ever be 5? 5, 4, and 3 adds up to 12, so no. 12 and 9 is 21 at maximum. It could be 6. Can it be 6? No, it can't be 6. 6, 5, and 4 add up to... 6, 5, and 4 add up to 15. 15 plus 9 is 24. So this has to be at least 7 here. So this is 7 or 8. Which means this cell has to see 3. It can't be 7, 8, and 9 that it sees. So it must... Okay, so then we have all the reds. Let's highlight now when we don't have all the reds. Let's basically try to highlight the cells that are seen. So we can remove all the colors for now. This sees 3 and 9 this way. This sees all 3 of these going this way. This must see the 7 or 8 because it needs at least 2. And if the only way this is blocking this is if this is 8 and this is 7, and then it would block everything else. So obviously it sees that. This is seen in one direction, but not the other direction. Okay, so let's see. If it's seen in the vertical direction, let's make it yellow. Okay. So this is yellow. Obviously, it's then the 9s are yellow. Or maybe, yeah, okay. Sees all 4 of these. So it does not see any of these cells in the vertical direction. I guess we'll do that with... light. It does not see in the vertical direction. I don't know. And then we have a different one. So this has to be, we'll make it orange looking this way. So it does not see any of these. It must see all of these. This 21 must see both of these. Again, if it blocks, if this cell's blocked, it would be 8 and 7. So it cannot be blocked. So it must see both of these cells, and then it cannot see another, can't see both 7 and 8 in this row because that would add up to 24 already. So it does not see any of these. So we'll, horizontally, if it does not see, we'll see that it'll be medium gray. Vertically, it'll be light gray. So again, this adds up to 16. You could have 1, 7, and 8. That could be fine. What's the maximum this digit can be? So this is 3 and 9, or 1, 2, 9. We're not sure which. So this is 1, 2, or 3 here. This is either 9 or it can't be 2. So this is 1 or 3 here, right? This is either 3 and 9 or 1, 2, 9. So this is either 9 or it's 2, and we don't know what this is. Okay. It will not be able to see the 3 here in this direction, in the vertical direction here, because there's going to be 5 digits in front of it. Again, we have 9 here. We have 9 in one of these two spots. And we're going to have 9 in one of these two spots. To add up to 21, it's 4, 7, and 9. Or, sorry, 4, 8, and 9. Or 5, 7, and 9. So this is 4 or 5 here. To add up to 38, we're missing 7. So it must see 9. It must see 8. Can 8 be any of these digits here? And the answer to that is no. Right? If you have an 8 here, 8 plus 9 only adds up to 17. If you have an 8 here, same with 8 and 9, adding up to 17. So 8 cannot be either of these digits. So where is the 8 then? It can be either here, or it could technically be here. Again, cannot be here, can't be any of these digits, because then that would close off the possibilities to add up to 38, because you'd have just 8 here, and then none of these digits are seen except for the 9. So you have 8, 6, 7, and 9 at most, which would be 30, which obviously this doesn't add up to. But you could have 8 here, and you could have 1, 2, and 4 here, right? And then this would be 8 and 9, or 8 and 9 with 1, 2, 4 here. So either this is 8 and that's 9, or this is 8 with 9 being one of these, and then 1, 2, 4 remaining here. So we're guaranteed to see an 8 in this column. To add up to 16, you could have a 9 here. So this could be 7 and 9. So this adds up to 1. This is 1 through 7 here. That's the reason why this couldn't be 8. This 22, you cannot have 7 here, because if you had 7 here, this would be 7, 8, and 9, or 7 and 9 that it would see. And that adds up to 16 or 24. Can it be 6? It could be 6 because 6, 7, and 9 add up to 22. So that's possible there. To add up to 15, it's only 1 through 6 as possibilities there. Okay. Okay, 21. 3 and 9. So those are seen. None of these are seen. So this is obviously seen. This is obviously... These two must be seen. Oh, it could be 3 something 9. So this is not even guaranteed to be seen here. So this is seen, this is seen. This doesn't actually... It could be 3 something 9 here. So this actually doesn't have to be 2 or 9. Interesting. This is obviously seen. This is obviously seen. I guess we'll just do orange from this side, because there's a decent amount of double scenes in each row here. This is obviously seen. Seen, seen, and seen. Can this be missing the 7? No. Because if it's missing 7, then where is 8 and 9, right? 7 would have to be not seen. It has to be before the 8 or the 9. Sorry, have to be after the 8 or 9 in this direction that's seen. And if the only way it could be behind an 8 or 9 is if this is 8 and one of these is 9. Right? If this is 8 and 9, 7 can't be behind it, and then it would be seen. So that would mean 8 would have to be here, and then 7 would have to be one of these. But then one of these cells would not be seen, so the 7 along with that is seen, guaranteed. In 38. Therefore, if this were 7, the problem is it would see this 7, it would see 8 here, and it would see 9 here. It would only not see 1. Oh, it could be further here. Never mind, that could actually work. In row 4, what is not seen adds up to 10. We know 9 can't be, so 9 has to be in box 5, one of these 4. In box 2, it's one of these 5. This is not seen by the 28. This is not seen by the 28, because if it were, there's just too many digits here, possibly, right? So this says at least 1 digit greater than 5. So this is also not seen in that column. These digits are not seen in this column, in column 3. 20. That means the remaining digits add up to 11. It could be 1, 2, 8. Oh, it has to see an 8. Right? So this must see an 8 in this direction. Because it's in front of the 9. And there's no other digit that can block the 8 from being seen. So this has to be 1, 2, and 8 to be seen. And since this is 1, 2, and 8 being seen this way, it must be 1, 2, and 8. Because otherwise, if you have any other digits in between, you are not going to be able, you will be able to see them, and therefore it add up to more than 20. So these are all seen. That means none of these are seen in either direction. And this is seen by both. So this cannot be 8 then, which means in column 9, we have to have 8 be here and 9 be here, which means this can't be 9 here. So it sees both of these. It obviously does not see the 1s here. So this is not seen here. So it must not see either 2 other digits in column 9 or the 6. So it would either not see the 2, 4 or not see the 6. That means it must see the 3. So it's either 2 and 3. So one of these is guaranteed to be 3 here. Because 3 has to be seen. Cannot be here. 2 can't be here either. If this were 4, 5, 6, the problem is it would have to see something behind it and then also the 9. There's no way that it can see 4, 5, and 6 with a lower digit to add up to 16, right? Because 16 minus 9 is 7. If you have 4, 5, or 6 here, that plus a low digit that it sees would add up to 7, but the problem is, obviously, it wouldn't see the lower digit. So then this has to be 7. So this is 7, which means it does not see this digit in the column. This is 7 and 9 that it just sees. It does not see any other ones. This has to be 2, 4, or 6 because it cannot see these digits in that digit in column 9. Remaining digits in box 6 are 3, 4, 5, 6, and 9. Obviously, 9 cannot be here or here. This can't be 3. This can't be 5, or it could be 5. No, it can't be. It could be 5. Okay, it could be 5 there. So we know 9 is one of these two. It sees the 8 guaranteed going this way. So this is seen vertically because it's in front of the 9. So we have 8 and 9, which means we either have 1, 3, or 4, 8, 9 that these are seen. And if we try to have 1, 3 here, then 3 cannot be here, and then 3 would not be seen in any of these cells here. So this cannot be 1 and 3. It must be 4, 8, and 9. Which means 4 in column 9 has to be one of these two cells. Well, if 4 is here, that means there's a 5 in front of it, which means it would not be seen. So either way, the 4 is guaranteed to not be seen in column 9, which eliminates then 1 and 6 as the cells not being seen. It must be 1, 2, and 4 then. And so this is a 2, and this must be 4 to not be seen. Because it's guaranteed to not be seen because there's a 5 definitely in front. So this must see all 3 of these cells, and it must be then, it sees the 7 also, obviously. So then it must be 3, 5, and 6 here. That's 3 in the corner. We celebrate because we know we're close to solving this. 4 cannot be any of these cells, cannot be here or here. So this sees 7, this cannot be seen. Either way. It could be seen okay, this can't be seen vertically. It's too small. So we're missing a 2 in column 8 sum. So that means it's 43 now. We have 12 that we have to be able to not see. 8 can... Okay, so remaining digits in box 9 are 1, 2. This has to see 4, and it cannot see any of these. It cannot see any of these in the column. So this has to be less than 4 here, and 3 is already guaranteed. Therefore, this is a 1, 2 pair. So this cannot be 1 and 2. We have 7, 8, and 9 remaining here. This can't be 9 because of 9 in the column. Sorry, in the row. That leaves these digits as 1, 3, 4, 5, 6 here. Okay. Remaining digits in column 7. We do not have 1, 2, 4, 8, or 9, so it leaves 3, 5, 6, and 7. Okay, so this sees 7. It could see that digit. This digit is going to be seen no matter what. So this is seen vertically. We have a 7, 8, 7, 8 pair in row 7. So that leaves the remaining digits as 1 through 5. Okay. To add up a 28, you cannot have 3 digits, so that eliminates 1 through... That eliminates 7, 8, or 9 there. Can you have a 6? No, because 6, 7, 8, 9 adds up to 30. Could you have 5? You could have 5. So this is 1 through 5 there. Cannot be 3 because of 3 in the column. This adds up to 19 this way. So if there is a 9 here, I don't think that works. Right? Because you have 7 and 9 here. Actually, that does this can't be 1, 2, 3, 4. Right? Because 1, 2, and 4 cannot be here. So this would just be 3 and 3, which is not allowed. So this cannot be 9 here. Because if this were 9, that would force this to be 5, 6, and 8 that it sees. Wait, that doesn't work. Hold up. It sees 7 and 9 this way. It would have to be... well, that kind of does work. Never mind. I don't know what my logic was there. That was not good logic. This cell will not see anything behind here. So this is not seen vertically. This is obviously not seen at all. This is not seen at all. 32, it will not see this cell vertically. This is fine. This is fine. This is not seen. It will see a lot of these. It sees 3, 5, 6, 7, 8, and 9 to add up to 38. 5, 6, 9 is 20, plus 3 and 8 and 7 is 18. So that's 38. This sees just 7 and 9. Yeah. So, the sums here must include 9 twice. So that's why I was getting confused there. This digit, then, what can it be? It cannot be 6 or higher. Can't be 5 or higher either. Because if it has 5, it must also see at least a 6. 5 and 6 plus 9 adds up to 20. So this must be 1, 2, or 4 here. Huh. Can the 9 actually be here? I don't think so, right? If this is 9, it would see all 4 of these digits. But this is at most of 5. So this would be 3, 4, 5, 8, 9 at most. And 3, 4, 5 adds up to 12. Plus 8 is 20. Plus 9 is 29. So not high enough. So this cannot be 9. So 9 could be here. Obviously, this could just be 6 and 9. So that would be fine there. There. Does not see the 2. It sees that digit. Remaining digits in row 6 are 4, 5, 6, 7. Okay. Let's try 25. What digits can be here? Can you have 5? 5 at maximum would mean this is 6 and 7. At least. 5, 6, 7 adds up to 18 plus 9 is 27, so that's too large. So it cannot be 5. This can't be 3 or 4. This is 1 and 2 then. So 1 has to be with 7 and 8 to add up to 16. 2, what would that be? 2, 16, it cannot be 5, 9. It would have to be 6 and 8. So either way, this is 8. Okay, that's good to know. So this is 8, which makes this 7. This must be 4, 8, and 9 to add up to 21. So this cannot be 4 here. And this can't be 4 here. So these two are not seen. This can't be 4, no 4, no 4. So we have 1, 7, 8, 9 that it sees. Or 2, 6, 8, 9. Adding up to 25. Neither of these can be 7. So this could be 1, 6, 7, 8, 9. That is possible. Or it doesn't see the 1 at all. You can't have 2, 6, 8, 9. Or actually, no, sorry. 1, 6, 7, 8, 9. It can't be 2, 5, 7, 8, 9. So the digits seen in this direction must add up to 10 besides the 9. Oh, 8 has to be in front of here. So it has to be 2 and 8 and 9 that it sees, because it cannot be any other combination of digits. So this is 2, and it must have an 8 that it sees. 8 can't be here, so this digit must be not seen this direction, or this direction. So this has to be 1. So this is 1, which forces 8 to be here, and to be seen that way. Now, 9 can be anywhere in between here. That's fine. That leaves in box 4, the remaining digits are 4, 5, 6, 7. None of these can be 4, so therefore this must be 4 here. That means none of these are 4. This is 5, 6, and 7. This is also 5, 6, and 7, which eliminates 5, 6, and 7 in the rest of the row. This can't be 5 or 6. It's 3. That means this can't be 3. This is 9. So this can't be 3 or 9 here. This becomes a 5, 6 pair. So 9 cannot be here. Oops. Or here. This is 1, 2, or 8. That leaves the remaining digit in row 4 as 3, 4, and 9. This can't be 9 because of 9 in the column. This is 8. This 1 eliminates 1 here, so this is 2 and 6 adding up to, with the 8 to add up to 16, with a 9 adds up to 25. 6 eliminates 6 here. Remaining digits in column 2 are 3, 4, 5, and 7, and we're guaranteed a 3 here, which means this cannot be 3, so this must be 1, 2, and 9 to add up to 12. Because we don't have the 3 available. So it sees all 3 of these. This can't be 1 or 2. It must be 5. So this cannot be 5 here. So we have a 3, 4, 7 triplet. This must see 5, 6, 8, and 9 to add up to 28. Right? Because it can't see anything lower than 5. So that leaves the remaining digits adding up to 23. 28 minus 5, which is 23. So it must be 6, 8, and 9. So this is 6, and then 8, and then obviously does not see any of these. 5 and 6 eliminates 5 and 6 here. So this is 7, this is 5, this is 6. This can't be 1 or 2 because of 1 and 2 in the column. Remaining digits in column 3 are 3, 5, and 7. This can't be 5. This can't be 3 because of the digits in the row. So this must be a 1, 9 pair here. So the 7, 2, 7, and 3 are not seen, obviously. The 6 and 8 are seen here. This can't be 1 or 5. This can't be 1 or 5. So it must see this digit. It will not see the 1. Okay, it's good to know. No 5 here. This cannot see 3 here, because if it sees 3 here, it would have to add up to 15 with the other seen digits. That would make it 9 and 3, because 1 and 2 could not be seen anymore. So this cannot be 3. Can it be 4? No. If it were 4, again, it would not be able to see the 2, which it would need to add up to 15. So this is either 2 or 6 here. This can't be 6, because if this were 6, 6, 7, 8, 9, which is all the digits it would see, would be only adding up to 30. So this can't be 6, this is 3 or 4. This can't be 6 because of 6 in the row. We know 2 has to be one of these digits here. So it sees one of these and it doesn't see the other one. These are seen here. These are not seen in either case. This is not seen in either case in the row. This is not seen because it can't be 9 in column 6. How did we know this was a 9? I think it was just where 9 could be in this row, right? It couldn't be any of these. It had to be there, right? Because then this would be too many digits. Oh. Ooh, that was a bad assumption. That was a bad assumption. It could be here. Oh. We might have to redo this. Dang it. Okay. That's not good. Okay, this is all the same, right? So it could be 3, 1, 2, 9. Ah, that sucks. Okay. Well, yeah, because that was a lot of assumptions made based off of that being 9. Okay. That was bad. That was a really bad assumption. You probably were, if you're watching this, you probably were already yelling at me. It's like, no, this doesn't have to be a 9. 9 could be any of these behind here. Okay. This is still the same. So 9 cannot be any of these to add up to 32. 9 cannot be here to add up to 38. 9 cannot be in front of any of the sums. So 9 does have to be one of those two. So therefore 9 cannot be in the rest of this box. 31, it cannot be here. Obviously not here, not here, not here. Cannot be 2 digits, so this can't be 9 here. Therefore, it's either 3, 1, 2, 9, or it's 1, 2, 9, or it's 3 and 9. So it must be 3 and 9 here. So this is guaranteed to be 3, and this is guaranteed to be 9. Again, it will see the 8 here, so this must be 1, 2, and 8, because those are the only digits adding up to 11 with the 8. And because we don't have a 3 available, so this is 8, 2, and 1. Okay, so 9 can be any of these 4. Yeah. Okay, not good there. Let's go to, so then 9 cannot be here. Right, so then we have, so 9 is guaranteed to be here. 9 is guaranteed to be here. This could be 9. 5, 7, 9 works. Okay, well, we're gonna have to do it that way then. Okay, so then let's see what we have seen. It has seen that way. This again, it cannot be just 2 digits with 9 because that adds up to at most 24. So all 4 of these must be seen in this direction, which means none of these can be seen. None of these can be seen vertically. Obviously, there's a 9 here. 1 can't be seen vertically here. It is seen horizontally. So this is seen, this is seen, this is seen. This is seen vertically, 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 and vertically. This is seen horizontally, vertically, vertically, and vertically. We don't, okay, so this cannot be 9 here. This still has to be 7 or 8. right? Because 6, 5, and 4 adds up to 15. 15 plus 9 does not add up to 25. It's 24. So this is definitely 7 or 8. So it sees that cell because, again, if it doesn't see that one, that would force an 8 here and then a 7 here, and it would only see 17 as a sum. Again, cannot see 7 and 8 and 9 here. So this is the only 7 or 8. It sees definitely 3. So this is still 4 and 5 here. Okay. And then it does not see this cell because it can't be 9. Does not see this cell because it can't be 9. Can't see that cell because it can't be 9. 8 can't be either of these. So this must be 8 and 9 here. So you have to have 8 and 9 there. We can remove the red, I guess. So it does see both of these. Again, this must be 1 through 6. 1 through 7. No, 1 or 2. If this were... It must... So either way, it has to see the 3 in this column. So this cannot be 3 here. Obviously, 1 can't be here. Again, to add up to 16, it would have to be 4, 3, 5, 2, 6, 1 with a 9. And it can't be any of those. So this must be 7. So that means it does see the 7. So this is seen. It does not see this cell vertically. And it could see this cell. We know we're guaranteed a 3 in one of these. Actually, 2 cells. So one of these has to be a 3. So this must be a 2 or a 3 here. Right? It either sees 2, 3, 4, 5, 7, 8, 9. Because 7, 8, 9 adds up to 24. 2, 3, 4, 5 adds up to 14. Or it sees 3, 5, 6, 7, 8, 9. So either way, this is 2 or 3. This could be 5. So this is either it sees the 8 here and the 9 is one of these two. Or it sees 5, 7, 9 here. It cannot be 3. Again, what are the combinations that add up to 16 here? Well, we don't know if 3's there guaranteed now anymore. What are the possible ones, though? You could have 4. So this is 1 through 4 here. 4, 5, and 7 add up to 16. 3, 5, 8, or 4, 3, 6, 7 adds up to 16. And it could be 1, 7, 8. So this is 5, 6, or 7 there. This is, again, 1 or 3. This has to be... To add up to 19, there's no 3. Remaining digits in row 6 are 4 through 7. Okay. Ugh. Okay, 9 cannot be here. So 9 could be here or one of these cells. Remaining digits in box 6 are 3, 4, 5, 6, and 9. Obviously, 9 can't be here. 9 cannot be here. 3 can't be here because it must be seen in column 9. Okay. Uh, 9 could be any of these 4. Okay, 21. So it either doesn't see this 8, which makes it 5, 7, 9, or it does see this 8, which makes that 4, 8, and 9, because it cannot be 1, 3, 8, and 9. So this is 4, 5 here. This cannot be 6 again. Can it be 5? No. Because if this were 5, adding up to 31, there's no combination that can ever add up to 31, right? It would either be 5, 6, 7, 8, 9, which is 35, or 5, 7, 8, 9, or 5, 7, 8, 9, which is at most 29. So this cannot be 5. This is 1 through 4 here, then. 19. You have to have 2 digits at least before the 9, adding up to 19. Oh, you can't have the 8 here again. So therefore, this must be 2, 8, and 9. Right? Well, 9 can't be any of these. So it must see the 2. It could be 8 in one of these 2 spots. The other one has to be 1 before it has to see the 9. So this must be 9 here. No, it can be the 8. Okay, so the rest of this row is 3, 4, 5, 6, 9. This can't, this could be 9. This could be 9. Oh. That's a lot more possibilities. Anyways, this is 4, 5, 6, and 7. 5 has to be seen. If 5 were here, it would not be seen because, well, no, it could be seen here. It cannot be seen there, though. So this can't be 5. At least, anyways, we do have a 4, 5, 6, 7 quadruplet in row 5, which eliminates 4, 5, 6, 7 in the rest of the row. This is the 3, 9 pair, which eliminates 3, 9 in the rest of the box. So that means this is 1, 2, and 8 still. Okay, so this is still the same. This is not seen vertically. This can't be seen vertically. These are not seen horizontally either way. If this were 9 to be here, that doesn't work. Because it would have to be once... Well, okay, there's no 2 here because of 2 in the column. If this is 9, this would have to be... You have to see all 4 of the remaining digits. So that would be 6, 5, 4, 3 at most. 3, 4, 5, 6 adds up to 18, plus 9 is 27. That's too small for this to be 9. So this must be 3, which makes this 9. Since this is 9, this must be 4, 8, and 9 to add up to 21. So it sees all of these. It does not see any of these. This must be smaller than 4, and it cannot contain a 3. So therefore, this must be 3 here. It does not see 1 or 2, because 2 is blocked by the 3. So then this must be 1, 2, and 4. So therefore, that's the reasoning that has to be that way. This is less than 4, so this must be 1, 2 as a pair. This must see 3, 5, and 6, so it must see all 3 of these cells. So it must see 3, 5, and 6. So that's still the same. That means this is 7, 8, and 9. It does not see the 3 here. That's going to be blocked by the 5 or 6, definitely. 2 is not seen. 4 is not seen. Okay. Nine is one of these 3. 9 can't be here. This is not seen horizontally. Actually, yeah, everything but 9 is not seen. This is 3 and 4, so this cannot be 3 and 4 here. How does this add up to 16? 1, 7, 8, or 2, 6, 8. Right? 2, 6, 7 is too small. That's 15. Obviously, you can't have 2, 7, 7. Yeah, so this is, either way, this is 8. So this is 8. This cannot be 5. So this is still the same. Then this is 4. So there's no 8 here. C's 4 and 8 here. This can't be 4. What are the possibilities for this? It must be 1 or 5, right? 6 would not work because you can only see either 6, 8, 9 at most, which is 23, or 6, 7, 8, 9, which adds up to 30, which is too big. So this is 1 or 5 here. This has to be 1, 2. Cannot be 3, because if it's 3, it must be 3, 3, and 9 adding up, but that's obviously not possible. Can't be 4, can't be 5, could be 6. So we have 1, 2, and 6 there. Here, we cannot have 5 or 6 adding up, because 5 would be at maximum with 4 digits, 5, 7, 8, 9, which is 29, which is too small. Or at minimum, 5, 6, 7, 8, 9, which would be 35, which is too big. So this cannot be 5 or 6 because of the same problems. So this must be 1 or 2. So we have a 1, 2 pair in row 9, which means the remaining digits are 5 through 9. Okay. And this cannot be 8 here. 9 cannot be here because of 9 in the column. Yeah, that's all we have, really. Remaining digits in row 7 are 1, 2, 3, 5, 7, 9. Okay, 9 cannot be here, 9 cannot be here. Because of the way that these work. This 3 eliminates 3 here, so this is 1 or 4. Four eliminates 4 here. So where we have a 5, 6, 7 triplet in box 4, which eliminates 5, 6, 7 in the rest of the box. So this is 4 here, which means this can't be 4. This is a 5, 6 pair, which eliminates 5 and 6 in the rest of the row. Okay. So all this is the same. We still don't have this necessarily. Though it was looking good for the 9 to be there. 8 cannot be here. Therefore, 8 has to be one of these 3 cells. Well, can't be here, so 8 has to be here. Therefore, we only see 3 digits here with a 9. Because the 8 will block everything else. So this will be blocked. And then this has to be 5, 6, 8, and 9. Okay, well, there's that. So this is 5, 6, this is 7. This becomes not 5 or 6 or 7, so this is 9. This has to be 1 because of the 1, 2 pair in the row. So this is 9, which eliminates 9 here and here. This 1 eliminates 1 here, so this has to be 2 and 6, which means this can't be 2, this is 1. This 8 eliminates 8 here, so this is 1 and 8. So this is seen going this horizontal direction. This is not seen in either direction here. So it sees the 2 and 8, does not see, it sees the 8, does not see the 1, and sees the 9. This is not 6 because of 6 in the box. No 1, 2. So this is 3, 5, or 7 here. This can't be 5 because of 5 in the row. These can't be 7 because of 7 in the row. This 6 eliminates 6 here, so this is 5 and 6. That leaves the remaining digits in column 2 as 3, 4, and 7. So this cannot be 3 here. It must be 1, 2, and 9. So it must see all of them. So it sees all of these vertically. This one eliminates 1 here, so this is 4. This can't be 1, so this is 2 or 6. This 4 eliminates 4 here. So it sees 4. Can it see 7, 8, and 9? Well, 9's one of these two, so this cell is not going to be seen. So it won't be seeing that anyways. Remaining digits in column 8. We have 1, 5, and 6. That's interesting. This is seen horizontally. These are not seen horizontally. So we have 9 and 2. That means the other digits must add up to 11. So it's either 3. It cannot be 3, 8. It's 4, 7, or 5, 6 that it sees. Remaining digits in column 7 are 3, 5, 6, and 7. If this were 7, that would see that, and it would see this digit here, possibly. So, I think this has to be 5 and 6, right? Because, again, they must add up to 11. It will not see the 1. 3, 4, and 5 adds up to 12, so that doesn't work. It must be 2 digits, cannot be 3, 8. And if we tried to have this as a 7, that wouldn't work, because it would have to be 4 and 7 that it sees to add up to 11 with the 2 and 9 that it sees. So this cannot be 7. It can't be 3, because then it would see the 3, and then the 3 cannot add up with the 8 to add up to 11, which is required for the remaining seen digits. So this cannot be 3. This is 5 or 6. Oh, wait, this could be 3 as long as this is 5. So this could be 3 here. But the thing is, the seen digits here have to be 5 and 6. And if this is either this is one of these two is 5. So it could be 1, 5, or it could be 5 with 3 there. 6 cannot, it could be 5, 6 also. So this can't be 6. But either way, this is either 1, 5, because it doesn't see the 1, and then it would see the 6 later. So it does see the 6 somewhere here. It sees the 5, and then it sees the 6. Essentially is what it has to be. We know 1 is one of these two. This can't be 5 because of 5 in the row. Remaining digits in row 1. Actually, this 1 eliminates 1 here in the rest of the box. So where's the 1? Okay, this 1 eliminates 1 here, so this is 2, which makes this 1. Okay. This 1 eliminates 1 here. To add up to 32, it cannot just be 6, 7, 8, 9. It has to have 5 digits to add up to 31 as the remaining sum. Remaining digits of row 3 are 3, 4, 5. This can't be 5 because we know 5 has to be one of these two. Since 5 can't be there, this can't be 5 here. Oh, this 6 eliminates 6 here. So this can't be 6. This is 1, which makes this 5, which makes this 6, which makes this 5. It will not see the 1 vertically here. It must see the 5 and the 6. That's 15. So it must see 7 and 9 as the remaining digits. 4, 5, 6. 7, 9. So it will see that digit no matter what. It must see the 9 here. It does not see that. So 4, 5, 6 is 15 plus 7 and 9 add up to 16. So 7 cannot be any of these cells. So it does not see the 7 here horizontally. 5 cannot be here. So this is 3, 6, or 7. I got stuck here because of the 6 here. Anyways, 6 cannot be here. This is 3, 4, 7, 6, or 7 here. And 1, I guess. 1 can't be here. So 1 is one of these two. Okay. Remaining digits in... Okay, so 8 cannot be here. Remaining digits in row 8 are 3, 4, 7, 8. Okay. 8 cannot be here. Okay, so this digit is always seen also. If you have 7 or 8 here, that means this is at most 1, 7, 8, 9. So this cannot be 7 or 8. So this is 3 or 4 here. This digit is always going to be bigger than these two. So this must be seen. This cell cannot be seen. If it were seen... Actually, this cell can't be seen either. None of these two cells can be seen. Because if they were seen, it's either 2, 4, 9 or 6, 9 adding as a seen cells in column 6. 6 can only be seen if it's over here. So this can't be seen either way. And if this is 2 and being seen, the problem is 4 would have to be here, which is not possible. So this cannot be seen either. Or vertically. Same with this cell. Can't be 2, 6, or not 2, 4, 6, or 9. 9 has to be one of these two. So these both cannot be seen vertically. Okay, so let's just double check. Column 1 sees 5, 6, 8, 9. 5, 6, and 9 is 20 plus 8 is 28. Column 2, we see 2, 6, 8, 9. 2, 8 is 10. 6, 9 is 15, which adds up to 25. 1, 2, 9 adds up to 12. That's all it sees. It sees, we don't have that yet. We don't have that yet. 4, 8, and 9 add up to 21. Those are all the ones that are seen. 4, 5, 6, 7, 9 adds up to 31 because 4, 5, 6 is 15. 7, 9 is 16. 15 plus 16 adds up to 31. 3, 5, 6, 7, 8, 9. 7, 8, 9 is 24, plus 14 of 3, 5, 6, that's 38. 2, 5, 6, and 9 will add up to 22. 7, this sees it horizontally too. 7 and 9 add up to 16. 2, 8, and 9 add up to 19. 3, 9 adds up to 12. 1, 2, 8, and 9 add up to 20. 4, 8, and 9, one of these will be seen, adds up to 21. So those are all, yeah. Yeah, that was a bad assumption there. But we got there anyways here from that. This will not be, it could be 2, 4. Never mind. 1 with 3 and 4. So it will never have the 2 as part of the set. Adding up. So it's 45 minus 32 is 13. 13 minus 2. That means we're missing at least 2 other digits. It cannot be missing... Well... So that means the other 2 missing digits add up to what? 11? Right, 13 minus 2 is 11. You don't have 1 that you don't see. Two's already included in the ones you don't see. So that means 3, 4, and 5 doesn't work. So it'd be 3 and 8, 4 and 7, or 5 and 6 that you don't see. So you don't see 3 cells. Okay. 8 is one of these two. Six could be here if 7 is here. Right? Remaining digits of row 1. We have 2, 3, 6, 7, 8. And we're guaranteed 8 has to be one of these two. Oh boy. Okay. Remaining digits of row 2. We have 3, 4, 5, 7, 9. And 9 has to be one of these 3 digits here. That's interesting. Could be 6, 9. Could be 2, 4. Can 9 actually ever be here? 6, 5, and 1, 2, 3, 4? 7, 8? Yes, that's possible. Okay. It sees these. Again, we're missing 2. We cannot see 2 in columns 4. We're missing either 3 and 8, or 4 and 7, or 5 and 6 in the seen cells. Huh. This is kind of difficult for this last part. We know 1 is one of these two. We know 1 is one of those two. That doesn't help, though. Can this ever be 8? Maybe? It would have to see all of these digits, right? So then you'd have to see 1, 3. This would then be 5. Because we have an 8 here, it would be 1, 3, 8. This would be 9 then. And it would be missing 4 and 7. We're guaranteed a 2 here also. Okay. 2 is guaranteed to be one of those 3. So this could be 8. That would force 4, 6, and 7 to be here. Does seem reasonable. Can this ever be 7? No. If this were 7, it would definitely see the 7 here, right? After here. So this cannot be 7. This could be 7 if this were 6 and 9, right? So if this is 6, when can 6 be here? 6 can never be here. If this is 6, then it would see, this would have to be 2. It would have to see 2, 4, and 9, but that would see 2, 4 here. This would be 6 here, so it would also see the 6 here if that were 6. So this can't be 6. This is kind of convoluted. If this were... Oh, that's interesting. So if this were 6 and 9, where is 9 in column 4? It would have to be here. So then these would have to be the missing digits. So it would be 9, 8, 6, 5, and 3. I think that works, right? Because it would be missing 2, 4, and 7. Yeah, 2, 4, and 7 add up to 13, which is the missing digits. So that kind of does work. So if this is 6, 9, that's fine. This is 9, 8. This would then be 9. I guess maybe the question is, what happened? When can this ever be 9 here? Oh, this can't ever be 9. Okay, so it leads to the same conclusion, but that was a bad assumption. But the thing is, if we had a 9 here... I mean, this could have been 9 here. We had to logic that out. But the same thing with this. If this is 9, there's no way you can have 2... Oh, wait, that's not true. This could be 9, 6 with 1 through 5 here. Okay, so... okay. Right. Or this could be 6, 9. Never mind. That logic doesn't work. Because if this could be 9, 8, 7 here. This could be 6 with 1 through 5 here. And that would actually still work. Because 6 and 9 are the only ones seen. If this were 7 here, that would not work. Because if this were 7, it would definitely see 2, 5, and 7, because this cell is greater than all 3 of these cells. So this cannot be 7 here. Oh, 7 can't be seen in any of these cells, right? And they would be seen if it's in front of the 9, so it cannot be in front of the 9, which means the 7 has to be behind the 9. So this is 7, which makes this 3, which makes this 4. That's interesting. That eliminates 3 in the rest of row 1, 4 in the rest of row 2. Okay. And then... Okay. The only way you cannot see 8 is if 8 is here and 9 is... Well, 9 could be in front. But the problem is 9... It would essentially be 8 here and 9 here if that were the case. Okay. This cell could be seen 2, 4. Oh. If this is 2, this cell will be seen. If it's not 9. And then the problem is it can't be 4 either way. So this cannot be 2, therefore this is 6. So this is 6, this is 7, which means this can't be 6 or 7. This can't be 6 or 7. This is 2, 8 as a pair. We have a 2-8 pair in column 4, which eliminates 2 and 8 in the rest of the column. So this can't be 2. This is 6. It could be just 9 here. This is not going to be seen no matter what. It still could be 1 through 5 here. Okay. Right, so... Oh boy. Oh, 7 eliminates 7 here. So this is not 7, this is 3. This can't be 3, this is 6. So it sees both of these horizontally. So it does not see any of these horizontally. This can't be 6, therefore it's a 3. This can't be 3, it's 5 or 9. 5, 7, or 9 here. This is definitely not seen vertically. We have a 3, 4, 3, 4 pair in column 4, which eliminates 3 and 4 in the rest of the column. This can't be 3 or 4, it's 9. This can't be 3, it's 5. Therefore, none of these cells are seen vertically. So this cannot be 9. This is 9 here. Again, so this must be seen here. This can't be 5. This must be seen, because if it's not seen here, these digits are never going to add up to 32. Right? You have 1, 4, 5, 7, 9 at most, if this is not seen. So that would be 1, 9 is 10. 4, 5, 7 is 16. 16 plus 10 is only 26. So this has to be seen, which means this has to be an 8. So this is 8, this is 2, this is 8. No 8 here. This is not going to be seen no matter what vertically. 5 eliminates 5 here, so this is 7. This can't be 7, that's 6. So it sees, again, to add up, this must add up to 13. So it's 2, 7, and 4 here, which makes this 3. 3 eliminates 3 here, so it's 7. 5 eliminates 5 here, so it's 3. 7 eliminates 7 here, so it's 5. So this cannot be 3 or 5 here. This can't be 3 or 7 here, and this can't be 5 here. 8 in... This can't be 9 because of 9 in the row. This can't be 6. 6 eliminates 6 here, so this is 7 and 6. 7 eliminates 7 here, so it's 5 and 7. 5 eliminates 5 here, so this is 9. This can't be 5 or 9. Sorry, this can't be 7 or 9, so it's 5. This 9 eliminates 9 here, so it's 2 and 9. 2 eliminates 2 here, so it's 1 and 2. 1 eliminates 1 here. This 8 eliminates 8 here, so it's 4 and 8. 4 eliminates 4 here, so it's 3 and 4. This can't be 3 or 4, so this is 1, which makes this a 3. Yeah, apologies. I was making a lot of assumptions there, which were incorrect. Everything else seems to work fine, as long as I didn't make the bad assumptions. None of these are seen. These aren't seen horizontally. This is obviously not seen horizontally. So again, vertically it sees 5, 6, 8, and 9, which adds up to 28. 5, 6, and 9 is 20, plus 8 is 28. 2, 6, 8, and 9 add up to 25. 1, 2, and 9 adds up to 12. 1, 3, 5, 6 is 15. Plus 8 and 9, 17 is 32. 6 and 9 add up to 15. 4, 8, and 9 add up to 21. 4, 5, 6, 7, 9 adds up to 31. 3, 5, 6, 7, 8, 9 adds up to 38. 2, 5, 6, 9 adds up to 22. 7 and 9 adds up to 16. 2, 8, and 9 add up to 19. 3, 9 adds up to 12. 1, 2, 8, and, oops, orange. 1, 2, 8, and 9 adds up to 20. 4, 8, and 9 add up to 21. And that's all. So, looks like this is the solution. So the 9 was there, but that was a bad assumption to make. We had to go through this part to make sure that this actually was a 9. And we didn't actually solve that until basically near the end. So, very interesting. Nice little puzzle, actually. The some skyscrapers, there's decent amount of restrictions, but there's not actually as many as you would think. Like, particularly here, I made a bad assumption with this, but the 9 could have been any of these, and obviously I had to redo everything because of that bad assumption there. So, be careful with some skyscrapers, but this looks like a rule set that you could extend in the future. It's pretty flexible, and it doesn't have, but it's still decently restrictive, I guess. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.